So I'm just going to go through this exercise 16a from our last lesson. So in that I already showed you me doing question 1, so I'm going to just start here on question 2. So before I've even read this question, I know I'm going to be making my UVAS list, and then as I'm going through the question I'll fill in the values. So a body accelerates uniformly from 2 meters per second to 6 meters per second. So V is 6, and it does that in 6 seconds, so that's the time. Part A is asking us to find the acceleration. So with my list and my knowledge of the equations, I'm looking and I'm thinking, right, what equation do I know that links U, V, A and T? So V equals U plus AT. So V is 6, U is 2, A is what we're looking for, and the time is 6. So if I take 2 away from both sides, I get 4 equals 6A, and then that means A is 2/3, or 0.6 recurring, or 0.67 meters per second squared. Part B then is asking for the distance covered, so it's asking us for S. So really I can use any of my equations now because I've got all the other values. I like to try and avoid using the thing I've just figured out, so I'm going to use S equals a half U plus V times T. Run out of room there. Fill in my values. So a half, U is 2, V is 6 and T is 6. That can just go straight into the calculator and it gets 24 meters. Okay, right, let's look at 3. So a body accelerates uniformly for 4 seconds at 1.5 meters per second squared. So that's the acceleration. Its initial velocity is 8. Find the final velocity. So again, we're looking for something that links U, V, A and T. So V equals U plus AT. So V is what we're looking for. U is 8, A 1.5 and T is 4. So that, okay, year 11, I've had a complete nightmare and messed up my recording big time. So I'm just going to show you what I had done here for 3, 4 and 5. I think from 6 onwards it's all okay from the original recording. So A ended up getting 14. B had asked for the distance. So I have used S equals UT plus a half AT squared. I've substituted in, so U is 8, T is 4, half A is 1.5, and then T is 4 again, so 4 squared. Type that straight into your calculator and you get 44 meters. Okay, question 4 then. Part A must have asked you for the final velocity. I forgot the questions are here. Yeah, the final velocity. So I've got my UVAS list, so check that with the question, check you're happy enough with that. Because I have U, S and T and I'm looking for V, then the equation I have to use is S equals a half U plus V times T. Substituting in my numbers, S is 100, U is 10, V is what we're looking for, and T is 8, so that's in there. This line to this line, I've just done a wee bit of tidying up, so 100, half of 8 is 4, right, and then brackets 10 plus V is still there. Now remember, this wee bracket here means 4 is multiplied on everything in that bracket. So my next step is to divide by 4. Your other option there could be to multiply out that bracket, but that's just giving you an extra step for the sake of it. So if we divide both sides by 4, we get 25 equals, and then we're just left with what's in that bracket, 10 plus V. Then take 10 away from both sides and we end up getting 15. B had asked for the acceleration. So because we have everything else, we can use any equation. So I opted for V equals U plus AT. So V was 15, just figured it out. U is 10, A is what we're looking for, and the time is 8. So I've just rewritten that like 8A, like more algebra-like. Taking 10 away from both sides gives us 5 equals 8A. Then divide both sides by 8, and we end up with 0.625. Okay, and then 5. A body accelerates uniformly from 3, so that's U, to 12 meters per second, covering 30 meters, so S is 30. Part A asks us for the time taken. So we've got U, V, S, and we're looking for T. So we have to use S equals a half U plus V times T. Substitute in my numbers. S is 30, half, U is 3, V is 12, and T is what we're looking for. So I've just done a wee bit of tidying up here. So 30 equals a half, 15. 3 plus 12 is 15 times T. Half of 15 is 7.5, and then divide both sides by 7.5, and you end up getting time of 4 seconds. For part B, it had asked for the acceleration. Now, I did 2 different ways for this. So really we can use any. The first way you can see here, I've used V squared equals U squared plus 2AS, but see if we use V equals U plus AT, it's much easier, okay? The only issue with that is if you've got T wrong here, it's going to be wrong here. So just pause and have a wee look at that one, and then I'll go back to the original video. Fingers crossed it's okay everywhere from then on, okay? Okay, 6. So make me UVAST list. Let's see, a body accelerates uniformly from 6 to 10, so V is 10, at an acceleration of 0.4. We're looking for S. Oh, so we are going to have to use this V squared equals U squared plus 2AS one. Right, so V is 10, U is 6, 2 multiplied by 0.4 for A multiplied by S. So see here, yeah, I'm going to take 6 squared away from both sides. No, do you know what? I'm going to do it out a bit nicer. So 10 squared is 100, 6 squared is 36, and then we'll tidy this up. 2 times 0.4 times S, 2 times 0.4 is 0.8, so 0.8S, right? If I take 36 away from both sides, that's going to give me 64 equals 0.8S, and then divide by 0.8. Oops, that'll get me 80. So S is 80 meters. Yep. Okay, and then B is asking me for the time taken. So I can use any of my equations here. The information that the question originally gave me was UVA, and I'm looking for T, so V equals U plus AT. So V is 10, U is 6, A is 0.4, oh jeepers, I'm hidden. Hold on. Putting the wrong thing. Do that. Zoom out a wee bit. Hold on, I'll fix this. Okay, hopefully that's a wee bit better. So 10 equals 6 plus 0.4t. So if I take 6 away from both sides, I get 4 equals 0.4t, and then just divide by 0.4. Gets me 10. So 10 seconds. Yep. Okay, let's go on to 7. So let's see. 7. A body reaches a velocity of 4 meters per second after accelerating uniformly for 12 seconds. So that means V is 4 meters per second. I'm reading the wrong question here. After accelerating uniformly for 12, so the time is 12 seconds and covering 36 meters, so S is 36. Part A is asking us for its initial velocity, so that's U. So we're looking for something that links U, V, S and T. So S equals a half U plus V times T. So 36, is that right, 36? Yeah. A half U plus 4 and T is 12. I'm going to tidy up. 36, a half times 12, I can simplify that to 6. Then I'm going to divide both sides of the equation by 6. So I get 6 equals U plus 4. Take 4 away from both sides, and I end up with U being 2 meters per second. Part B is asking us for its acceleration. So ideally I would be looking there to use V, A, S and T. However, that doesn't exist. So I'm going to use V equals U plus AT. Good old faithful V equals U plus AT. So 4 equals U is now 2 plus A multiplied by 12. So take 2 away from both sides. So 4 taken by 2 is 2, and then I've left the 12a. Divide by 12, and I get 2/12, which is 1/6. What's that as a decimal? I know I should know that. 0.1, oh, I'm not even on the screen anymore, 67. So any of those will do there. Okay, right, let's look at 8. So, where am I? A body accelerates uniformly from 4, so u is 4, for 4 seconds. Nope, I read that wrong. 6 seconds, sorry, I've put this so small on the screen. At 3 meters per second squared. Find its final velocity. So I'm looking for something that links u, v, a, and t. V equals u plus at. Hopefully you're seeing that that is the one that comes up an awful lot. I'm just going to type that in. I get 22 meters per second. Right, part B, what is this question? 8b, the distance. So I'm looking for s here. Do you know what I'm going to use? S equals ut plus a half at squared. Now remember, at this point the world is my oyster in regards to these equations, as long as it has s in it. So if you hate rearranging equations, then you could try and get your unknown to be the subject of the equation, or if you're looking back to see using the ones which have, like, that were originally given to you in the question, this one comes out top as well, because we were given u, a, and t, and we're looking for s, and they're the things that appear in this equation. So s equals u is 4, t is 6, plus a half multiplied by a, which is 3, multiplied by t squared, and t is 6, so 6 squared. I can type that straight into my calculator, and I get 78. So s, 78 meters. Okay, so question 9. A body accelerates uniformly at 4 meters per second squared, covering 152 meters, in reaching a velocity of 35. So v is 35. Find its initial velocity. So I'm looking for something that links u, v, a, and s. So that is going to be v squared equals u squared plus 2as. So plugging in my values. Okay, I'm just going to work out this all as one number, and I might just do 35 squared while I'm at it. Okay, so that's that done. So 35 squared gives me this bracket gives me this. So if I take 1216 away from both sides, that gets me 9. So then I just need to square root both sides. Square root of 9 is 3, square root of u squared is u, so u is 3 meters per second. Part B then is the time taken. Probably v equals u plus at is the easiest one to use here. So v is 35, u is 3, a is 4, and t is what we're looking for. So if I take 3 away from both sides, I get 32 equals 4t. Divide by 4 and I get 8. Oh, nearly wrote the wrong unit. 8 seconds. Okay, 10. Let's see, a body accelerates uniformly from 8. So u is 8 meters per second. For 4 seconds, time is 4, covering 80 meters. Find its acceleration for part A. So I'm looking for something that links u, a, s, and t. S equals ut plus a half at squared. Okay, I'm going to try and slow down here my rearranging because this one's awkward enough. Substitute in my numbers. S is 80, u is 8, and t is 4, plus a half multiplied by a multiplied by t squared, so 4 squared. Tidying up as much as I can before I start like taking things away or whatever. So 80 equals 8 times 4 is 32, plus a half multiplied by a multiplied by 4 squared. 4 squared is 16, a half of that is 8, so I can rewrite that as 8a. So all of a sudden this looks like a much easier equation to solve than this, but it's the exact same, it's just tidied up. So if I take 32 away from both sides, I'm going to get 48 equals 8a, and then if I divide both sides by 8, 48 divided by 8 is 6. So a is 6 meters per second squared. Okay, b. 10v, it's final velocity, so we're looking for v. Probably the easiest one to use here is v equals u plus at. Yeah. So v is, u is 8, a is 6, and t is 4. So that gets 32 meters per second. Okay. Right, so 11. Body accelerates uniformly from 2 meters per second at 3.5 meters per second squared, traveling 159.75 meters. Find the final velocity. So we're looking for something that links u, v, a, and s. So v squared equals u squared plus 2as. So v squared equals 2 squared plus 2 times 3.5 times 159.75. That I can type straight into my calculator. So that gets me 1122.25. Then if I square root both sides, I get 33.5. So v is 33.5 meters per second. Okay. Right, part B. I must be asking for the time, is it? What number is this? 11. Yeah, the time. V equals u plus at. So v 33.5. U is 2. A 3.5 times t. So if I take 2 away from both sides, I'm going to get 31.5 equals 3.5t. Divide both sides by 3.5. That's wrong. So 33.5 divided by 3.5 gets me 9.57. No, sure, I typed the wrong thing into my calculator. 31.5 divided by 3.5 gets me 9. Okay. So t is 9 seconds. Right, 12. So a body accelerates uniformly at 1.5 meters per second squared for 2 seconds, acquiring a velocity of 10 meters per second. Find its initial velocity. So u, v, a, and t, v equals u plus at. V is 10, u is what we're looking for, a is 1.5, and t is 2. So 10 equals u plus 3. Take that away, I'm going to get 7 meters per second. B is asking for the distance travelled, so that's s. Let's go with s equals a half u plus v times t. Honestly, we could have used a bunch of those. We could have used s equals ut plus a half at squared. We could have used v squared equals u squared plus 2as. This one I think is probably the easiest to use in this case because one, s is already the subject, and it's just an easier equation than s equals ut plus a half at squared. Okay, so where am I? S equals a half, u is 7, v is 10, and time is 2. So I can type that straight into my calculator and it's going to get 17 meters. So 13. A body accelerates uniformly from 9 meters per second to 30 meters per second. In travelling 136.5 meters, find its acceleration. So we're thinking what lengths u, v, a, and s? V squared equals u squared plus 2as. So 30 squared equals 9 squared plus 2 times a times 136.5. Will we do a wee bit of tidying up? Yeah. So let me just talk you through what I've done here. 30 squared is 900, 9 squared is 81, 2 multiplied by 136.5 gives me 273. So this again all of a sudden looks much nicer to solve. So I'm going to take 81 away from both sides, right? So 900 take away 81 gets me 819. And then I'm left with 273a. So then I just need to divide both sides by 273 and I get 3. So a is 3 meters per second squared. Part B then must be asking us for the time, is it? Yeah, the time. Let's go v equals u plus at. So v is 30, u is 9, a we've just figured out is 3t. If I take 9 away from both sides, I get 21 equals 3t. Divide by 3, I get t is 7 seconds. Okay, last one, 14. A body accelerates uniformly from 9.9, so u is 9.9 meters per second, to 33, so v is 33 meters per second, in 6.5 seconds, so that's the time. Find its acceleration. So what links u, v, a and t? V equals u plus at. So 33 is 9.9 plus a times t, so I'm just going to write that as 6.5a. So I've substituted 6.5 in for t, but we don't normally write a 6.5. We only normally write the number after the letter, so that's why I've written it that way. Take away 9.9 from both sides. Gets me 23.1 equals 6.5a, and then divide by 6.5 gets me 3.55. I'm just going to round it off. Okay, and then part B, the distance travelled. Let's see, u, v, s and t. S equals a half u plus v times t. Plug in our numbers. U is 9.9, v 33, and t 6.5. Oh, don't need that wee bracket there. Oh well. Type this in. 9.9 plus 33 multiplied by 6.5 gets 139.425. Okay, that's them done. So hopefully if you were stuck that helped. It felt rushed, but I can just see that it is 20 minutes, so I'm going to shut up really quickly now. But you can just scroll to whatever questions you need. No point me saying this at the end. Right, okay, bye.